Hey, what's going on, guys? Comeback again zero. Last video we've been printing a single bit board, and we've defined the function called print bit board here, making use of the three absolutely essential macros, bit manipulation macros that was created even earlier than the last video, but that doesn't really matter that much. So the particular topic of this video is actually how on earth to take all the bit boards for all the pieces, for all the piece types. And for those of you who don't know how many there should be, I'll say this again. So there would be up to 12 bit boards to represent every single piece type on the chessboard. So white pawn, white knight, white bishop, white rook, white queen, and white king, 6, and plus 6 same pieces but with a black color. So we'll need up to 12 bit boards in order to actually being able to represent the entire chessboard position. So we'll start basically with defining some new variables here. So first of all, let's actually try to define our bit boards. And there are different ways of doing this. For example, like last video, we've been doing this by simply saying U64, which is the type of unsigned long integer in C, up to 64 bits in an integer there. So we could have made it just like we did the previous video, like white pawn and then black pawn, then white knight, and so on until we get the black king, basically, right? But it's not really that effective in terms of the engine's workflow and the code size also. So I just want to share one trick of how many chess programmers actually use to define the bit boards. Obviously, I'm not doing this within the board structure, which is generally a good practice. I will just define this as a global variable, just as a proof of concept, basically. So if we just define the bit boards array of up to 12 elements, it already does the trick for us. So we have an array of bit boards where every element would represent the specific piece would represent the specific the bit board of the specific piece type. So we'll have the index of 0 would be the bit board for white pawns, the index of 1 would be the bit board for white knights, and so on. But so in order to not forget this, let me also define pieces, or encode pieces. Well, it's better to say define pieces, so we can enum the pieces the following way. So pawn. So I'm using these ASCII characters as the constants that will serve as a constants to represent the integers. This would have been needed within the print board function, just to write less code and to optimize the code from the size perspective. So pawn, knight, so this is so uppercase letters are white pieces. So pawn, this is knight, then the bishop, rook, queen, and king, and then we go for black pieces. So we got pawn, knight, bishop, rook, queen, and king. So up to 12 pieces here. And also I want to define ASCII pieces. In order to actually use, I want to define the array of ASCII pieces here. So this would be character array. So ASCII, and actually character pointer, because yeah, I would like to define them as a string here. So we'll have the same. So pawn, knight, bishop, rook, queen, queen and king, and pawn, bishop, rook, pawn. Oh my god. So again, pawn, knight, bishop, rook, queen, king, pawn, knight, bishop, rook, queen, king. So it's important to if this order is defined like this order should be the same. That's essential part here, and you will now understand why exactly this is about to be like that. Okay, and now we can already make use of our pieces that we define here. So let's say first let's I just want to show you one little thing for the debugging purposes regarding how to use this encoded pieces, and then we'll go to implementing our print board function. So let's initialize white pawns bitboard, and I can simply say bitboards indexed by p, which stands for the white pawn, so p equals to 0, so literally bitboards indexed by 0 would it be equal to some sort of a value, but obviously we can make use of our setBit function, so we can simply say setBit and then pass in our bitboard for white pawn as the first argument, and then let's specify the square of, say, E2 here. And after, I just want to print the bitboard. Print the bitboard of the white pawns. So I'm sending this bitboards indexed by the white pawn, and hopefully, okay, I just need to compile around this. And hopefully, I will see the bit that is responsible for the E2 square to be turned off from 0 to 1. So in order to compile this stuff, we need to say gcc bitboard.c and -o to specify the output file. We'll call this bitboard, and if it compiles, I want to run the bitboard binary executable here. Okay, so yeah, just as expected, we have this bit being set on E2, and also we have the decimal representation of our bitboard, which doesn't say much, but just for the clarity purposes, I did this in the previous video. So here is our pawn. But also, I would like to, well, let's define a couple more pawns here. So say E2, say D2, and say F3, like this. So we now have a look. We have these 3 pawns being set up pretty randomly on the board. And now let's just add a couple more knights into this position, because the implementation that we're supposed to be making obviously won't really rely on the number of pieces. So whatever number of pieces are available, all of them would have been printed. But first, I just want to give you an idea to realize the very details of what we're supposed to be doing here. So now let's initialize white knights bitboards, because you know, like there are some bitboard tutorials on YouTube, but they are pretty complicated. Well, at least when I was a beginner, when I just started this stuff, they didn't really help me much, and I really needed to pick up everything from scratch on my own. And if I watch them now, obviously I understand what's going on there, but the point is just to help the absolute beginners to kickstart with bitboards. So that's kind of, I mean, not absolute beginners in C programming, but absolute beginners in bitboard chess programming. I mean, that sort of a thing. So now let's set bit to the bitboards indexed by n, which stands for white knight, and let's put them on initial position. So say G1, and also want to put one on B1. So if you just now print the bitboard, oh, sorry, not for the bishop, but for the knights. If you just print the bitboards for knights, we see that 2 knights has been just placed on the G1 and B1 square. So now we have up to 2 bitboards, so we just can print the bitboard for our pawns and the bitboard for our knights. We have 2 bitboards being initialized. So now we need to map these bitboards, so so eventually we'll have a human readable chessboard without these zeros and ones, but with the ASCII pieces represented, with the ASCII characters represented the chess pieces instead. So this is the idea here. And let's actually go for this. So I'm using this print bitboard just for the debugging purposes. Obviously, it won't be needed later on. So just to make sure that our print board function would be working correctly. So it should place the pawns exactly on these squares and place the knights exactly on these squares. So from now on, let's actually start defining our print board function here. So this would be the wait function called print board, and it's literally the same as within the print bitboard, but let me just implement this from scratch. So to make it to explain how it works one more time, basically. So the very first thing, we need to loop over board ranks, and you can simply say for int rank is equal to 0, rank is less than 8, and increment rank via rank plus plus, and then we need to do the same for the files, and here we say int file equals to 0, int file less than 8, int file plus plus. So now let's initialize the square. So in order to calculate the index, the square index, we need simply to say square equals rank multiplied by 8, because 8 is the width of our chessboard, and plus file, like this. And the next thing, let's print our ranks actually. So here we can simply say if file is equal to 0, or in short just can say if not file. In this case we want to print our rank, sorry, oh my god, decimal, like this, and to map them accordingly we need to say sorry 8 minus rank, like this. And every time we hit a new rank we want to print a new line here, so printing a new line like this. So let's actually, so here we do print bitboards, and here we can finally call our print board function. So print board, like this. Okay, so we have our ranks. Now let's also specify our files. So print files, so printf, and 1, 2, 3, 4, A, B, C, D, E, F, G, H, and a couple of new lines there. Okay, and yeah, I just need to shift this one more. Okay, and probably make like this. Okay, perfect. And probably I would also need to add a new line at the very beginning just to prettify the layout. Obviously it's not essential, but I really like this things getting prettified. Okay, and now we're coming to the most essential part. Just let me, so we need to initialize the piece variable here. So let's say int piece equals -1. Why -1? Because if it would be equal to 0, it would be like a white pawn already, but we want to make sure that if we don't hit any piece within our bitboards, I'll now explain how exactly we would be doing this, but to make sure if we don't hit any piece within our bitboards, in that case that means that the square is empty, so we need to track that accordingly. So okay, I'm just wondering what would be the better way of doing this. Okay guys, just hold on a sec. Okay, so probably we would be using the ternary operators here, so just print piece print piece here. So printf, and we're gonna be using this character formatting because our ASCII pieces are supposed to be the type of character. So, and here we just ask, I'm using the ternary operator, so that we now need to evaluate the expression. So if piece equals -1, so if true, then we need to print this dot. Otherwise, for now I will use just a placeholder, because let's put this to O, or even null like this, just because we didn't yet provide logic of picking up the particular specific piece. So just a placeholder for a ternary operator just for now. So now it should print all now it should print all the dots, okay, within our chessboard, because like no pieces are getting initialized. And now the most essential part and the most intriguing part, we need to gonna initialize the piece to the particular particular value if there is a piece in the correspondent bitboard. Oh my god, this is so hard to explain. Okay, let me just write some code and try to explain this along the way, so I'll provide a commentary. Okay, so now we need to loop over bitboards. So this is the most essential part. We now need to loop over the array of our bitboards. So remember that the bitboards is an array of U64 or unsigned long integers. And oh my god, where's the definition here? So we can loop over this, and in order to index, we could have also obviously we could have indexed like from 0 to 12, but to make it even more readable and understandable, we'll use this pawn and king precoded piece values here. So okay, so here I can simply say like for int bitboard piece, I'm creating the bitboard piece variable here, equals to pawn, bitboard piece is less than black king, so to make sure that we cover the range of all the piece codes available, and bitboard piece plus plus. Okay, so now we need to figure out if the current piece okay, again, like, oh my god, so if, and we need to get bit and the bitboard indexed by the bitboard piece, and the index would be the square, right? Oh, sorry, get bitboard indexed by the piece, yeah, and the square is the index to shift the bits within the get bit macro. Okay, so if this is true, in this case piece would be equal to bitboard piece. Okay, and oh my god, excuse me, bitboard, oh, bitboards in plural, I guess. Okay, yeah, so now now my placeholder kind of works, because it now gives an idea of where the pieces are located, but we didn't yet distinguish the pieces themselves. So in order to do this here, instead of this null, we need to reference our ASCII pieces array indexed by the piece, and now this should give us a valid excuse me. So did I just... Oh, hold on a sec. Not like this. Not like this. Why did I do this? Why did I make it a pointer? I want to make it an array of characters. So, oh, ASCII also. Yeah, I didn't call this ASCII pieces. So now this should work. Yeah, perfect. So we got our pawns and the knights being printed on board. Okay, so before we continue, let me just try to explain how exactly this works. So the most essential line is right over in here. So we're getting a bit, and we're using the index equals to the current given square. So we're kind of like asking, okay, so we're kind of asking our bitboards. We say like, okay, we got a square of, let's drop the indexes themselves. Let's call the squares like with the human readable coordinates. And we say like, okay, we got the square E2. Is there a piece on E2 square on whatever bitboard? So that's the question. So is there a piece on a square on the current bitboard? And if yes, then we are setting the piece variable that we just created before to this BB piece, bitboard piece, which stands, which serves as the counter to index the bitboards. So this means like, so first we say like, so this is the loop where we loop over all the piece types, and p equals to 0 and k dark king equals to 12. So in other words, we'll say like bitboards equals bitboards indexed by 0, which stands for white pawns. Is there a piece on the bitboards of white pawns at a current given square? If so, then we use the value of the counter that actually finds this index to index the bitboards, and this counter would already be the piece encoded right over in here that we can use as an index later on to index the array of ASCII pieces where we did so like that's why the mapping should be the same. Okay, so we use the encoded piece value in order to index the ASCII pieces array to get the corresponding ASCII character for a current given piece, in case if this sort of a piece is actually found on a bitboard of a specific piece type at a given square. So this is the whole trick of how to unite all the bitboards into one single board. I mean, like, we're not really doing anything to bitboards, so we're just asking the bitboard if there is a piece or not. And the idea is just we just presenting this, we're just inspecting all the bitboards in one run, like to get the information regarding all the available pieces and what particular square does the current given piece presented on one or another bitboard is occupied. So is occupied by. So what piece is the current square is occupied by. Okay. So let me instead of trying to explain this even more, let me try to add a couple more pieces, and now let's go for black pieces. So we can say like we can say like init, let's say black king. Okay, and we can set bit, and we can use the bitboards indexed by the black king, and let's put this to E8 square. So from now on, the black king should appear right over in here, so little k should appear in that square. Let's have a look. Excuse me, why it doesn't appear? Did it compile? Oh my god, this is very strange stuff here. Okay, let me print the bitboard for kin. Oh, this is getting a little bit interesting. Okay, we got the kin on the bitboard, so the bitboard is initialized correctly. But oh, that's the reason why this is happening. Last equals like this. Okay, now this should work. Okay, we got this black king, perfect. Obviously, yeah, so index equals to 0, or the biggest number for index would be 12, which stands for white, for black king. Okay, so hopefully it works. And let's also initialize, white king. Bitboard and bitboard here. Bitboard set bit and bitboards indexed by the white king. Let's put them to E1. Okay. Oh, come on. Comma? This is a semicolon, sorry. Okay, so now we have this white king and black king. And the very last thing, guys, I'd like to share with you, if you're on Windows, I have no idea how to do this, but if you're on Linux like I am, I just want to open my current bitboard engine, a bitboard engine I'm currently working on, in order to grab some Unicode characters for representing the chess pieces. So just grab them, and here just use these Unicode pieces. And now if you're on Linux, you're able of doing the following thing here. So here I just can say printf, and now this would be a string specifier because Unicodes are longer than the casual characters, so needs to get represented by string. And here we have the same, but instead of ASCII pieces we can reference the Unicode pieces. So again, like, let's have a look at this Unicode pieces. So literally the same like in here, but just like a little bit different definition. So we would be returning this cute chess pieces instead of the ASCII characters. But some developers don't really like that. They prefer these letters, but I personally really like things sorry guys, getting prefied. So I really like, oh my god, I did something horribly wrong. I'm just wondering, yeah, that's because here we need to specify this as the string. Okay, so now if we just, unfortunately I can't zoom this in, but I hope you got the idea. So we have this Unicode characters representing our pieces in such a cute way, so we can visually see like what piece occupies the particular given specific square. So at this moment we did initialize up to 1, 2, 3, 4 bitboards, right? So white pawn bitboards, white knights bitboards, black king bitboards, and white king bitboards, and we did unite, and we did kind of grab all the bitboards into one, and eventually we did print this board position based on the information that is taken from the bitboards. So this kind of stuff is absolutely essential, and really hope that from now on it would be quite pretty clear, like how in particular, as the title of this video claims, so how can we unite all the bitboards into one in order to print the chessboard position from this sort of a bitboards. I would also need to think how to entitle this video in the most appropriate way. So this is it from my side, guys. I hope you learned something interesting out of following this tutorial. Thanks for watching. Until the next time, and take care.